Hey everyone, and welcome back to The Explainer. So today we're doing something a little different. We are literally pulling back the curtain on computation itself to expose this massive hidden flaw that's just sitting at the very foundation of modern computing. We're diving deep into part 4 of our 12-part masterclass. And listen, if you care at all about the future of AI, legal accountability, or honestly just how your everyday devices actually work, you're going to want to pay very close attention to this one. We're going to look closely at the physical engines driving our digital world and discover exactly why we desperately need to change them. Okay, let's kick things off with a question that might just break your brain a little bit and challenge your basic assumptions. Do computers actually process absolute truth? Think about it. When you ask an AI a super complex question, or when a massive system calculates a huge data set, is it giving you an undeniably exact, mathematically perfect answer? Intuitively, we all think, well, yeah, of course it is. It's a computer, right? If you type 1 plus 1, you fully expect an absolute, undeniable 2. But what happens when you ask it to calculate the square root of 2, or, process billions of parameters in a neural network? Well, get ready for this, because the staggering reality is 80 to 90%. Yeah, you heard that right. That is the percentage of AI compute cycles that are actually just hardware-level approximations. They're not exact mathematics. When these massive language models or agent networks are doing their heavy lifting, they're overwhelmingly using hardware that fundamentally just guesses the nearest mathematical truth. And the craziest part? This isn't just some software bug we can easily patch with a quick update. No, this is a hardwired, physical reality of how our modern AI server farms operate today. So here's our game plan for today's Part 4 Masterclass. We're going to start by unpacking the hidden hardware flaw. Then, meet the two opposing forces inside our chips, the FPU gambler and the ALU surveyor. After that, we'll talk about restoring data provenance and wrap up with our ultimate goal, achieving forensic accountability. All right, moving right into Section 1, the hidden hardware flaw. Let's dive straight into this grand computational illusion happening deep down inside the silicon. To really ground this idea, I love how the source material's Kyle McLean-Smith frames it. He says, it's fundamentally an approximation system, not real arithmetic. Man, that perfectly anchors the whole problem, doesn't it? The physical engine driving your incredibly advanced AI isn't actually calculating absolute ground truth reality. It's essentially an estimation system. The machine is physically bound to make highly educated guesses just so it can process massive amounts of continuous data really quickly. So who's exactly responsible for this flaw? Let's jump to Section 2 and meet the antagonist of our story, the floating point unit, or what we like to call the FPU gambler. It's fast, it's lossy, and it is totally unauditable. You can think of the FPU hardware reality like a gambler frantically throwing darts at a dartboard. It is specifically designed to approximate heavy matrix operations incredibly fast, but and here's the catch, to achieve that blistering speed, chip manufacturers literally burn their own proprietary, completely secret seed tables directly into the silicon. What does that mean for you? It means your computer's approximation of a complex equation might actually be slightly different down in the decimals than my computer's. This causes what's known as a non-deterministic drift. Because the underlying physical math is literally a corporate trade secret, getting exact one-to-one mathematical reproducibility across different machines is physically and mathematically impossible. And this lack of precision leads to something researchers call the wood chipper effect. Here's how it goes down. Step 1. The AI ingests exact source data, like a copyrighted book, financial records, you name it. Step 2. The FPU hardware approximates the math using those secret silicon tables we just talked about. And Step 3, because that math was just a guess and not a precise trackable calculation, the original data provenance and identity are just lost forever. The FPU acts like a giant blender. I mean, you know exactly what fruits you tossed into the blender, but you absolutely cannot reverse engineer that smoothie back into the exact fruits it came from. This totally destroys the chain of title and creates an unmanageable legal liability. But hey, it's not all doom and gloom. The hero capable of restoring absolute order has actually been sitting inside our computers this entire time. Let's get into Section 3, the exact ALU surveyor, our deterministic antidote. When you put these two forces side by side, the difference is completely night and day. The FPU gambler is fast, sure, but it's lossy, unauditable, and relies on those sketchy secret seed tables. But the arithmetic logic unit, the ALU surveyor, it is the exact opposite. If the FPU is a gambler throwing darts, the ALU is a surveyor out in the field with a precision laser. It is strictly deterministic. It performs exact, verifiable arithmetic. 1 + 1 = exactly 2 every single time, with absolutely no hidden seed tables involved. And because it operates the exact same way on literally every single CPU on Earth, it serves as a globally accountable universal witness. You can see it represented in these exact bit streams, almost like those pulsing gliders from Conway's Game of Life. Unlike that foggy, probabilistic realm of AI neural nets, the surveyor deals only in exact, discrete logic gates and bit streams. It's just a completely reliable foundation. High voltage is a 1, low voltage is a 0. It executes on a perfect metronome of clocked voltage. No guessing, just facts. So, the big question is, how do we actually fix this hardware flaw and bridge the gap between our messy human intent and this perfectly rigid hardware? That brings us to Section 4. Restoring data provenance and baking in the chain of title. We cross this massive divide using what the sources call the semiotic bridge. This is basically the universal deterministic interface. You see, our fluid probabilistic human imagination, which the material refers to as OS alpha, just cannot directly interact with cold, hard silicon. We have to use structured text like C code or JSON to act as sort of a divine script. By intentionally shifting our core math functions entirely away from the FPU gambler and handing them over to the exact ALU using rigid, deterministic code, we can safely compile our intent into exact hardware execution. By utilizing this semiotic bridge and strictly relying on the ALU, we bypass those sloppy approximations entirely. This actually restores a principle from physics known as Noether's theorem of reversibility. We can literally work backwards. Every single decision traces back to a highly auditable, mathematically absolute path. This is huge because it helps us completely avoid the 50% critical line. That really dangerous point where FPU approximation errors compound so heavily over repeated tasks that your data just degrades into pure statistical noise. Which brings us to the high-stakes, real-world impact and our ultimate goal in Section 5, achieving forensic accountability. Truly, this is the only path forward for high-liability AI. Look, we are hurtling toward a future where AI isn't just going to be generating fun images or summarizing your morning emails. It's going to be handling high-liability fiduciary duties. We are talking about AI managing massive enterprise finances, negotiating incredibly complex legal contracts, and acting completely autonomously in the real world. For that level of trust, we absolutely must demand deterministic accountability. We need the absolute guarantee of forensic precision and verifiable truth at the hardware level. No more probabilistic guesswork. Because here is the absolutely crucial point. Hardware-level floating point anomalies have literally caused catastrophic failures in critical infrastructure in the past. When human lives, legally binding contracts, and frankly trillions of dollars in the global economy are on the line, we simply cannot afford an AI that just guesses the answers based on a hardware gambler. We need the mathematical receipts. We need the cost of trust to drop to zero, simply because the math itself undeniably proves the chain of title. So I want to leave you with this final provocative thought. Take a moment today to really think about what runs underneath your systems. When you build, when you invest, or when you regulate, are you relying on an illusion of fast approximations that completely destroy data provenance? Or are you demanding the absolute forensic truth of the surveyor? Honestly, the future of how we trust artificial intelligence depends entirely on how we answer that question. Thank you so much for joining me on this explainer, and as always, keep questioning the world around you.